The diagram shows for a wire carrying a current I, and what does this current represent? We need to analyze this, and we need to tell what does this current represent in these 4 points. Alright, so let's analyze them one by one. So we know that whenever the current is flowing in a certain direction, we are sure that this is the direction of the conventional flow of electrons, okay? Although the electrons must be flowing this way, okay? They must be going this way because the conventional current is opposite to the original flow of electrons, right? So now we can say that, let's analyze them one by one. Okay, so part A, option A says the charge flowing past a point in a wire per unit time. Okay, so it is about the charge, the flow of charge per unit time, although current is equals to Q over T, right? The flow of charge per unit time. So yeah, we can go with that. Yeah, that seems okay. Let's mark it and let's analyze other points as well. The next is the number of electrons flowing past a point in the wire per unit time. No, actually this is not correct. Why? Because the definition of current is the flow of charge per unit time. Right? We are not concerned about the flow of number of electrons. We are always concerned about the flow of charge. Alright, so this cannot be an option. Alright, for option C, they're saying the number of positive nuclei flowing past a point in the wire per unit time. Again, we are not concerned of the positive nuclei. We are only concerned about the charge. Alright, and charge is, it could be negative, it could be positive, right? And current is always negatively charged, the flow of negatively charged electrons, right? So again, this cannot be an option. And lastly, the option D, which is the number of protons flowing past a point in the wire per unit time. Again, the charge should be negative and it couldn't be proton because proton got a positive charge. So yeah, we should go with option A.